Hello everyone, I am Shiv Prakash, Research Scholar Department of Electrical Engineering, IIT. Today is the assignment number 11 for the in this session you will tell about the grid connection of a PV channel, how to interface the grid by the PV. There are two types of load like a stand-alone system, and second one is the grid connected system with a PV panel, a PV system. If you have a PV system, there is some voltage of PV, like a terminal voltage of PV is Vt and current of It. In a standalone, you simply apply a DC converter. After that, you connect the load. This is a load voltage. This is duty cycle D to control the DC converter. And for a maximum power point, you apply with terminal voltage of It Vt and apply an algorithm here. After that, you a PWM, it will generate the duty cycle and give to the DCC converter. It will work on the MPPT, maximum power point tracking, in the standalone system. This is the standalone system. Many type of load like a battery charging of a battery or water pumping, like that. This one is standalone system. But sometimes if you generate the large amount of energy and you want to pay to the grid, then this is the grid connected PV system. Because the PV system is generated at the DC voltage, to convert in AC you have requirement of inverter, and how to control inverter in such way the power will be supply from solar to the grid, not a grid to the solar. There is one controlling, use of and controlling, and how you control the switches in such way to supply a current from PV panel to the load grid. In the PV system, same. And sometime in the modern time, is some simply use of this converter. After converter, it will use inverter here. Sometime it will use the transformer also. After that, you can connect to the grid. This will be the grid connected. To maintain the output voltage here, VSC, you have requirement of the DC voltage. Here the capacitor is used, output of the DC converter, large capacitor to maintain the output voltage. The DC link voltage. This is the DC link voltage. To maintain the output voltage, you can control DC. By the DC, you can control the output voltage of the inverter in such a way. This is like a, mostly this is used as a boost converter because of the step up voltage from some voltage to a level of the voltage which one is applied to the load to the grid. But if you don't want to use a DC converter, then you can simply apply an inverter here. After that, you transformer and we connect it to the grid. In DC buck converter, if you want to apply supply to the grid, then sometime transformer are not also requirement because of the boost converter is boost the voltage in such a level you can convert the inverter, you control the inverter voltage as a grid voltage. If you want to inverter, direct use of inverter to the MPPT by MPPT in the solar panel, simply use a inverter, can use a inverter. This voltage is not enough to that directly connect to the grid. That's why you have requirement of a transformer. After transformer you can connect the grid. You can use ITBT, this one, or the MPPT, and generate the reference signal to control the this voltage or this current. We talk about three-phase grid connected system. First of all, we have a PV panel. There are some voltage VT and current of IT. There is an inverter. In three-phase inverter, I have 6 switches. The three-phase supply. After that, you can connect a transformer to step up the voltages. Then this is a voltages connected to the grid system. The voltage, I can say this is a VRYB, phases of RYB. We can use as a filter also to maintain, to control this current controlling, and harmonics reducing also. To control the switches of three-phase inverter, the requirement of the grid driver and pulses PWM. We have a requirement of 6 switches. You have a 6 switches. In one leg, I have a 2 switches. In three-phase inverter, or 3 leg RYB, it will be 6 switches. Sometimes gate driver have a one input and one output system, but some gate drivers have one input and two outputs. Two parts is like complementary output, like one positive, one negative. If you have a single input, a single output driver, then you have requirement of 6 pulses. For one driver, we have requirement of one pulse. For a microcontroller, this will PWM will generated by the microcontroller. But sometimes have some drivers have a single input and dual output. Output will be a complementary, like half bridge driver. If you search about the half bridge driver, it will input of one same thing. Have a 8 pins of driver. I think you know like IR 2104 data number. This is the half bridge driver. You can give the pulses here between two terminals. This is the voltage supply VDD. This one. This is the upper bounded. This one for the lower terminal of a switches. This will generate as the positive wave, and when this is the positive wave, it's the negative. It means you develop when this will be positive, then this will be a negative in complementary. This will be zero. Sorry, this will be zero. When this is in zero, then this will be a positive, like that. You can this will connect for the upper layer. Up, this is for the lower high side or low side. So the high side driver, this is the low side driver. You can control by the only one given only one pulses because of the inverter 3-phase inverter. I have 6 switches and 2 is work in the complementary, like like that. This is phase A, B, C. A, if this is high, and this will be definitely low. Then you can give of this driver given supply by the this driver. The positive you can give here and negative you can give from for here for this one switches. Then if this is the high, this is a low, and this is the high, and this is a low. In that condition, you can you have used only a 3 driver to drive the 6 more switches. There is some controlling the how to control this for 3 phase. You have 3 quantity. The use of controller. To generate the duty cycle like that. After that, it should be going to the PWM. PWM generate the pulses in an inverter connected to the grid. Then what is the difference value? Voltage or current? How do you want to control voltage? You want to control a voltage or you want to control a current? Is a different thing. Voltage controlling or current controlling. By a VT you can control as MPPT algorithm. You can apply. After that, you get a reference value. Same reference value you can connect here at the A, B, C. The same thing you can connect A, B, C here. This is the low. This is the F reference value. This is the actual value. In place of ABC, you can put the voltage or current. But in the grid connected system, you know about the grid system, the voltage will be constant. a constant voltage at a grid. Then when the voltage, if you when you connect a inverter or any converter to a fixed voltage supply, like if you see in DC converter, when charging the battery, when you charge the battery, then battery voltage will be constant, and you can't be increase or decrease the voltage of output voltage of a DC converter. In that case, you control only the current, not the voltage. You control the current, how much current you can flow to the as how from how much current you want to charge the battery. Same thing you can apply here also for the grid connected system. In grid connected system, voltage will be fixed. Then voltage will fix. Then you control the current only. Then you can sense here for IA, for IB, IC, because of the voltage will be fixed. Then no need of the controlling our voltage. Then you apply controlling current, because of current controlling. By a current controlling, you can control the power, because of the voltage is fixed. Then current will vary. Then current is valid. Then Vi is the power in AC system or AC system. Vi cos phi, like that. Then if you control the current, then you can control the power. How much power you want to feed to the grid. The same thing you can calculate the IA, IB, IC, current controlling. This is the IA reference signal. Then how much IA, IB, and IC. But this is the AC signal. You know about this one also. This is the AC system. Suppose we generate a AC reference also. This is the IA reference. And this is the IA. IA may be different type of IA. Sometime you can say this is the phase shifted IA also. Maybe. Then how you track the IA in your controller? Then how you whose controller you want to use? If you want the PI controller, you know about the PI controller. PI controller, the DC system, you know about reference signal. Suppose you fix the voltage like VDC, something 10 volt, and this is the fixed voltage only. It is not a variable signal with respect to time. It will be fixed in all time. The output also VDC or output voltage of the DC converter. After that, you use the PI controller, and this will generate the PWM. And go to the duty cycle to the DC converter. In this condition, if you use a PI controller, then there is the fix of the voltage. DC voltage will fix. Then to fix voltage, this is a reference voltage. Then you can track easily like that. You know about the response of PI controller like that. You can control the easily track. But in the AC system, they are different thing. Your reference signal also vary with respect to time, and the output signal also vary with respect to time. Then how you track this one? If you want to add this, if suppose this is the same signal, there is some tracking. Maybe can track this system. But in that case, what happened? This is starting from here, but there is the same phase is shifted. Then how to control this one? That is the different. This is the difficulty in the AC system controlling. They are using a in this system where the tracking controller, but there are the many type of problem in tracking controller, like a low bandwidth to control this, the signal. Or you, and you use a three like in that system use the same controller as a three controller for a three phase. You need of a three controller for three phase, and same time it will work because of you control the all signal. This is the AS AB phase A signal, same time have a some phase B signal, phase C signal, like that. Then that type of signal controlling is a very difficult. Too easier to make a easier of this one thing, the AC system, whole three phase system is converted in a constant DC signal, equivalent of the constant DC signal, to control this type of signal. Use of a controller. In that controlling, if you have a constant signal like this one, this type of signal, if you have a constant signal, then you use any controller like a PI controller or any controller in that signal, because of your reference signal will be constant. And the whole three phase AC system, it will be converted into two phase DC system, equivalent to the DC system, known as the DQ transformation, direct axis and quadratic axis transformation. If you convert this one three phase ABC into a DQ system, DQ is the fixed quantity, but angle will be changed. Is there, but the magnitude will be fixed in the whole time, D axis and Q axis. And that signal you can control AG by using a PI controller. That's why the three phase conversion is needed of three phase to the AB to the DQ transformation. But you can't be controlled directly a three phase ABC signal. You should have to control into three phase AC signal to two phase AC signal, like alpha beta. This is the two phase AC system, three phase AC system. This is two phase system. After that, you control the DQ transformation. This is the DC signal. First, to control the alpha beta. After that, you control the DQ system. This is the process to controlling a three phase AC system to the equivalent DC system. And after DC system, D and Q value is fixed. If you change the DQ value, the magnitude of the ABC signal will be changed, and you can control easier by using a DQ control. But how you control, how you convert this one three phase AC signal into a two phase AC signal? After that, DQ transformation means the two phase DC system. You know about the AC system, a three phase AC system. A displacement of 180 degree. B second one is the C phase. All of the displacement of 120 degrees. 120 degree. To convert it into two phase AC signal, we are use of the alpha beta transformation. This one, In alpha beta, both are displaced to be 90 degree. This is alpha, this is the beta. You talk about the voltage. The same thing you can say this is a VA voltage, BB voltage, BC voltage. In place of voltage, you can use up the current also the IA, IB, IC. This is the alpha angle. Then this is the V alpha. You can say this is the V beta. In alpha beta system, V alpha beta. Know about the V alpha is displacement of a 90 degree as J V beta. Same thing. I take as this is the beta alpha. Sorry, this is the take as the alpha. 90 degree of this one is the beta. Then what is the alpha? What is the V alpha, V beta? V alpha and V beta. How you calculate V alpha, V beta by the three-phase system? ABC. If you have a ABC system voltages, then how you convert the alpha and beta in alpha beta? This is the vector diagram. Okay, this is also known as the space vector. Follow the vector diagram is then any signal if you want to calculate that this signal is what is effect of the other signal in that signal is calculated by the projection. Same thing if you want to first one you want to known as alpha. What is the value of alpha? What is the effect of the VA on V alpha signal vector? The VA is the same direction of the V alpha. Then this is the same value. To convert the alpha beta transformation, you can control as differently by VA. What is the value of VA with respect in alpha direction, and what is the value of VB in alpha direction, and what is the value of VC in alpha direction? If you calculate this one, then you can find the easily. Then if you can want this one is the total VA, because of the VA same direction of the alpha, angle will be 0, then VA cos alpha. If any difference is there, then cos, apply a cos, and the angle between them is a projection of any vector on that vector. Like example, if you want to calculate the V alpha effect of the VB on the V alpha, then simply apply a VB plus VB of a cos signal. Then what is the difference? What is the angle difference between them? This angle. This angle will be 120 degree. Then simply apply 120 degree. Same thing. If you want to calculate the effect of the VC on a V alpha, then supply a VC into take a cos and the angle of this one. Always angle measure by the anti-clockwise only. If you measure in clockwise direction, then take a negative value. Then this will be a cos of 240 degree.
240.
Yeah. Same thing if you apply to calculate the V alpha, V beta, V beta, same thing. You can apply V beta. Then what is the value of VA? What is effect of VA on a V beta? This is the V beta, this is the VBA. What is the effect of VA on V beta? Same thing, apply VA into cos. What is the angle difference between them? 90 degree, take a 90 degree. plus V beta. What is value? What is the effect of the VB on V beta? And what is the angle between them? This is the 90 degree. Then the remaining is a 30 degree. The angle difference between the two is the 30 degree. It will be a VB cos of a 30 degree plus what is the angle difference between them is 30 degree plus 180 degree is the 150 degree. BC cos of 150 degree. And what is the V alpha? Value of VA, same thing VA 180 degree 120 degree cos 120 is minus of 1 by 2 to VB 240 degree minus half BC V alpha. This will be 0 cos 90 is 0 cos 30 is root 3 by 2 VB cos 150 is minus root 3 by 2. It means if you want to calculate a V alpha, so this is the V beta. This is the vector ABC. This value of VA, VB, BC. This value of 1 minus half 0 root 3 by 2 root 3 minus half root 3 by 2. This is the alpha beta conversion of the from the three phase ABC. In simple way, take a three phase ABC as vector VA, VB, VC. After that, take a V alpha. V alpha taken as the same phase of the VA, and after 90 degree of this one is the VA beta, and apply V alpha and the effect of the all three phase on a V alpha along with a V alpha. Then simply apply cos. Why cos? You know about this one? There is a triangle. No, suppose this is the A, this is the B, any vector of us like R. And what is the value of projection of the R on the A vector? This is the theta. This is the hypotenuse. This is the base. Then how to apply cos? Cos theta is equal to base by hypotenuse. Now what is the value of B? Simply apply vector. This is the R. You know about this one. This vector same as the R divided by R. Then what is the B? The value of effect of the R on A vector is the B or cos theta. Same thing I apply here. If you take a 90 degree of this one, same projection if you want to take here, what is effect of at a 90 degree? It means it a B vector projection of R on B vector. Then simply apply as a This is the sine. This is the sine. But don't confuse there. Only apply two angle. Take a cos and take a angle between them. You can calculate it easier. Same thing I apply here to calculate the alpha and beta. After alpha beta, you can calculate dq. dq is very easy to calculate after it. Suppose dq, I written different thing. I written here. We have already calculated. This is the v alpha. Suppose this is the beta axis. I take it as a v beta. D axis take at some angle of this one. D, BD, VK at some angle like a theta. Then how calculate VD? Now calculate VQ. I alpha beta, V alpha and V beta. You know you have already calculated the V alpha, V beta here from the ABC. After that, you calculate the VQ, VD and VQ. Same thing, same projection apply and same angle. Then what is the effect of V alpha on VD? Same, it is V alpha into angle between them, cos angle between them is theta, then simply cos theta plus beta. What is the beta? V beta, sorry, beta, effect of V beta on VD. Then what is the angle between them is 90 minus theta. Okay, cos 90 minus theta. Total angle is 90 here to here. This is the 90, and what is this one is a 90 minus theta. This angle is 90 minus theta. Then what is this one? Vd, V alpha cos theta plus V beta sin theta. Vd is calculated. And what is Vq? Then forget all of thing. Same thing apply for the V alpha. And what is the angle? What is effect of the V alpha and Vq? And what is the angle between them?
Theta.
Yeah, same thing, theta. Then Vq is V beta. Sorry, if you take a V alpha first, then what is the total angle? 90 plus theta, V alpha cos 90 plus theta. Okay, plus same second V beta is cos theta. This angle is be theta only. Then VQ is equal to V. This will be what is the minus of V alpha cos sin theta plus V beta cos theta. Then VD, VQ. If you want to take in a vector form, this will be V alpha, V beta, and V alpha multiplication of cos theta, beta multiplication sin theta, This is the minus sine theta. This is the cos theta. That's simple thing. First convert in V alpha beta. After that you can control the V d V q. Simply apply a angle difference only. Take a magnitude and multiplication of the cos angle between them. Now I've taken the question. What is the question? Let VR, Vy, Vb, the three-phase system is a 10 sine 100 by t. Vy is a 10 sine 100 pi t minus 2 pi by 3, and Vb is a 10 sine 100 pi t plus 2 pi by 3. With the voltages in stationary reference frame Ry by Ryb that have the R axis, Y axis, and B axis displaced by a 120-degree apart. These three voltages are transformed into a DQ rotating frame, which rotating which is rotating at a frequency of 50 Hz. In DQ frame, this is the value of VD and VQ is fixed. The magnitude of this one magnitude and VDQ system, a DQ transformation system. This is the magnitude of any vector. Magnitude is fixed for VD and VQ, but this angle will be changed. It will rotate like that. Angle may be 0 to 360-degree. It will rotate like that. Then this is the VQ DQ system, DQ transformation system, DQ theory. BD and VQ any function in D axis and Q axis the fixed magnitude, but angle it will be rotating. The same thing is saying here. It will be frame DQ rotating frame. This is the rotating frame. It will rotate. The alpha beta is not rotating. It will be angle difference. Rotating frame which is rotating at a frequency of 50 Hz. Rotating at a speed of 50 Hz. Where the DQ axis is lying along the voltage space vector, then the value of VD. Same thing asking value of VD. First of all, apply the calculate the alpha, beta, V alpha, V beta. After that, you can calculate the VD and VK. V is 10 sin omega t. Magnitude is the Vm. I take as the Vm. I take as a general system. After that, we putting a value of Vm and omega. Take as Vr is Vm sin omega t. Vy is same thing Vm sin omega t minus pi by 3 2 pi by 3 120 degree. V is a Vm sin omega t. You can take as a plus 120 degree or minus 240 degree. It will be same. are the V alpha and V beta. V alpha, no, VR plus minus half Vy minus half Vb, Va minus half Vc, Vb minus half Vc. We already calculated here V alpha, Va minus half of Vb minus half of Vc, and beta, V beta is a Va is a 0 because of it will displace at a 90 degree. Then plus of root 3 by 2 Vb and minus of root 3 by 2 Vc. You put the value here Va, Vr is Vm sin omega t, and Vy is half of Vm omega t minus 2 pi by 3, and half of Vb plus 2 pi by 3. Take as a Vm is common. This is the sin omega t. This sin a minus b. Sin a minus b means sin a cos b minus cos a sin b. Sin a minus b, sin a, it means sin omega t, into cos b cos 2 pi by 3 minus, this is minus, this is the in expression also in minus, the minus minus will be plus cos a sin b, cos a which means cos omega t, same thing, half half is multiplied by here also, sin 2 pi by 3 minus comes here sin a plus b, a plus b it means sin a cos b plus cos a sin b of sin a cos b sin omega t into cos 2 pi by 3. This is the plus expression, and this is the minus, minus multiplication with the plus is minus, minus cos omega t into sin 2 pi by 3. Take what is the cancel here. This is the half cos omega t into sin 2 pi by 3. This is the half also here. I forgot this one, sorry. This is the plus half cos omega t sin 2 pi by 3 minus of half cos omega t sin 2 pi will be cancelled out. This value will be same. The cos 2 pi by 3 is, which means cos 120 degree. Cos 120 degree is minus 0.5. Same thing, cos 240 degree, cos 240 degree also 0.5 minus 0.5. If you have some confusion, then simply take away from. This is the sign. What is the cos? Like that. This is the pi, 2 pi. The question is this cos 2 pi by 3. This is the pi by 3, 2 pi by 3, pi 4 pi by 3. This will causing is the 0 here. 6 pi by 3. Sorry, 5 pi by 3. This is 30 degree. This is the 5 pi by 3. This is the 6 pi by 3 or 2 pi. If you have a confusion in cos and sine, and what is positive and negative, know about 60-degree value is 0.5. This is the not the same at same point. There are some differences. This is comes here, I think. Okay. This is the 2 pi by 3. 2 pi by 3 here in negative in cos. Then 4 pi by 3. 4 pi by 3 is also in negative. In both condition, cos will be negative. And cos 60 is 0.5. Then cos 120 is minus 0.5. Cos 240 is also minus 0.5. This is a negative value. In terms of sine, the sine 2 pi by 3 is positive value, and sine 4 pi by 3 is negative value. And this is the 60, 120, sine 120 and sine 240. Okay, leave it all of them. This is the cancel out. This is the minus 0.5. This value is minus 0.5. This is value. This value also minus of 0.5. Minus minus plus minus minus plus 0.5 0.5 by 2 it is 0.25. 0.25 is 0.5. V alpha is equal to Vm sin omega t. This is the 1 by 4 sin omega t. This is 1 by 4 sin omega t. Both are 1 by 2 sin omega t. This is the 3 by 2 Vm sin omega t. Is equal to V alpha. And what is the V beta? V beta is 0 plus root 3 by 2 V y minus of root 3 by 2 V b. This is the expression I already calculated here. Plus root 3 by 2 b Vb minus root 3 by 2 Vc. Then root 3 by 2 can common. As Vm is both Vi and Vb, then Vmi is also common. Then y is sine omega t minus 120 degree 2 pi by 3 minus sine omega t plus 2 pi by 3. If you know about sin c plus sin d value, you can apply sin c minus sin d directly. Or if you forget this one, this formula, then apply sin a minus b minus sin a plus b. Both are same. The sin a cos b minus cos a sin b here. Sin a cos b plus cos a sin b here. Cos a sin b cancel out. Sin a cos b only remaining. Sin a minus b. And sin a cos b sin omega t into cos 2 pi by 3 This will be negative, as a negative in sine formula. Cos omega t into sine 2 pi by 3. Okay, this is a negative. Sine omega t into cos 2 pi by 3, negative, and formula also negative. This will negative, since the formula positive, because of this is sine positive. Cos omega t into sine 2 pi by 3. This will be cancel out, sine terms, minus sine 120 is root 3 by 2, root 3 by 2, then root 3 by 2 is this is same, cos root 3 by 2 it will be root 3 only, minus root 3 cos omega t. So what is v beta? Root 3 root 3 will be 3 minus of 3 by 2 Vm cos omega t. This is the v beta. Alpha beta we estimated, v alpha and v beta. Now you can calculate the Vd and Vq. Vd and Vq. Vd is v alpha cos theta plus v beta sin theta. Vq is minus of v alpha sin theta plus v beta cos theta. V alpha is 3 by 2 Vm sin omega t into cos theta. V beta and V alpha both are 3 by 2 Vm. Then I will common this one, 3 by 2 Vm cos omega t. Here cos omega t V alpha into cos theta, cos theta. This is the beta, V beta is minus 3 by 2 Vm, will be common, minus cos omega t is remaining, and minus cos omega t into sin theta. This will be cos A sin B minus, sorry, this is sin A cos B minus cos A sin B. It means sin A minus B. It means 3 by 2 Vm sin A minus B. It means omega t minus theta. In the VQ transformation, both are 3 by 2 Vm. This is the common, 3 by 2 Vm. I take as a common. This is minus sin theta, and this is the sin omega t. It will be minus sin omega t into sin theta. This is the 3 by 2 Vm beta, V beta 3 by 2 Vm is common. The remaining is minus cos omega t and cos theta. This will be negative because of there is positive, minus cos omega t into cos theta. Both are minus, I can take a minus outside, then this will be a sin A sin B plus cos A cos B, or you can say as a cos A cos B plus sin A sin B. It means cos A minus B. This is minus common, this will be minus 3 by 2 Vm cos A minus B. You can next take as there this cos A cos B minus plus A sin B. Then VD is 3 by 2 Vm sin omega t minus theta. VQ is minus 3 by 2 Vm cos omega t minus theta. VD in VQ is depending on the theta value. If theta is same rotating with omega t as the same frequency like fundamental frequency of 50 Hz, theta is also rotating at 50 Hz, then this angle will be 0, then sin 0 is 0, then VD all value is 0. VD value is 0 here. It has VD and VQ value. VD, VQ once again. This will be 3 by 2 Vm sin omega t minus theta. Okay. In the question, what is saying question? Question is saying that these three voltages are transformed into DQ rotating frame. DQ rotating frame which rotating at a frequency of 50 Hz. The rotating frequency theta, the rotating frequency is 50 Hz. Then what is the theta? Theta is 2 pi f into t omega t. You can say this omega is different, then I can take as omega dq theta dq t. Theta is omega dq t, then dq is the 50 hertz. Dq is the 50 hertz. Omega dq is it means it will be 2 pi f dq into t. This is the 50 hertz. Then theta will be 150 into 200 pi t. And what is in question? Omega t fundamental is 100 pi t also. That is omega also is 100 pi. Omega is 100 pi. Then omega t is 100 pi t. Both are same frequency. Both are rotating at a same frequency. Sin omega t minus omega t. This is same. I take written as Vm sin omega is 100 pi t. Theta also 100 pi t. 100 pi t minus 100 pi t is 0. Sin 0 is 0. Vd value is 0 in this question. Minus 3 by 2 Vm cos same 100 pi t minus of 100 pi t. It will be cos 0 value is 1 minus 3 by 2 Vm. Vm is given in the question as 10. This is Vm is given as a 10. Then Vd is 0, Vq is minus 3 by 2 into 10. It will be a minus of 15. Value of Vd is 0, Vd value is 0, Vq is minus 15. This is the Vq. Next question. I think this next question same related question. VR same thing. 10 sin omega t py 10 sin omega t minus 2 pi t. BH voltage is stationary reference frame RYB, that is RYB axis, it is by 120 degree apart. This is voltage transform into DQ rotating frame which is rotating at the 20 hertz. Where the Q axis is lying along the voltage space vector, then the frequency of the signal in the DQ axis frame is In dq, same thing, you know, vd, vq. I have already calculated 3 by 2 Vm sine 100 pi t minus theta. Theta is different because of rotating at 20 hertz only. This will minus 3 by 2 Vm cos 100 pi t minus theta. Then what is the theta? Theta is 2 pi f dq into t. 2 pi into 20. Frequency given is the 20 and theta is 40 pi. And what is the Vd? The 40 pi, 100 pi minus 40 pi, it will be 3 by 2 Vm sine 60 pi. This is the frequency omega is a 60 pi. Then it will be 2 pi f is equal to 60 pi. Pi will be cancelled out. F is equal to 30 hertz. This is C option. You can observe here if a if a dq axis rotating at the same frequency of a ABC, in that condition, then Vd and Vq have a constant value. Here, these are a constant value Vd and Vq. When it is a constant, when the rotating dq frame is the same frequency at the ABC as a three-phase system frequency, then this is the constant value. But when these are the different rotating at a different frequency like 20 hertz, then in that condition Vd and Vq have some frequency component also. It is rotating at a different frequency. It will not a fixed quantity. Vd and Vq is not a fixed quantity. Vd is the sine 60 pi t, Vq is the cos 60 pi t. This is not a fixed value. If you, these are rotating at a different frequency as a three-phase system. I think this question at the same, it was asking about the VQ. The frequency, it will be rotating at the same frequency, 50 hertz. Then what is value of VQ? VQ 0, sorry, VD 0, because this is the previous question also. Related to the previous question, we calculated as VD and VQ. Three by 2 Vm sine 100 pi t. If this is the 50 hertz and 2 pi t, theta will be also 100 pi t. 0. VQ is minus 3 by 2 Vm. This will be cos 0 minus 3 by 2 Vm. Already calculated, Vm is 10, it will be 15 minus of 15 VQ. It is expected to send sorry. This question start here from here only. If the three phase voltages are transformed into a two phase stationary frame alpha beta with a horizontal axis and as a vertical axis, alpha is a horizontal, beta is a vertical axis, then the loci of a voltage space vector in alpha beta frame will be with a circle with a center at 0 0 and radius of 10, a circle with a center of 0 0 and radius of 15, and ellipse with a center of 0 0 and with a major axis and minor axis length of the 10 and 15, and an ellipse with a center of 0 0 and with major axis and minor axis length of the 10, the square root of 3 and 10 respectively. This is alpha, this is the beta, the three phase you know. This is the A, this is the B, C. In three phase AC system, if magnitude are same, voltages magnitude are same, then resultant vector is a 3 by 2 of a Vm. It will be constant vector anytime, anywhere. Who can observe this one? Resultant is the radius of a circle with a alpha beta axis. You take as angle 0, pi by 3, 2 pi by 3, pi, 4 by pi by 3, 5 pi by 3, 2 pi. Or y start from a 120-degree apart. So y b, and we started from here. VR, VY, sorry, VB. This is the VR. At any point, you talk a resultant vector. Like if you take like one point here, suppose you talk about the here, you take this as a 1 magnitude, then this will be the point five only. Magnitude always will be same in the three phase AC system. Then this is the A. If you take R, that is the VR, and remaining two are negative, negative but same value as a point five only. Or I take a negative as a here, the negative here is VA, VB, VC minus VC minus VB. This will be half of this one, point five, point five. What is the effect of these two vectors on this? What is effect of minus VB and minus VC? This is VC and VB on this is the point five on this vector VA. Now you can say this is the V alpha. The V alpha is this is the VA, total VA plus the projection of this one on that here. VA is 1 by 2 into cos of 60 degree. Angle difference between them is 60 degree only. Cos 60 degree. Point 0.5 half inch means point 0.5, point 0.5. If we take this one, this will be a 3 by 2. This is the radius 3 by 2. If you take as a one quantity, it will be some Vm, multiply Vm. Also, you know alpha I already calculated as 3 by 2 Vm into some angle into rotating. Maximum is the 3 by 2 Vm. This is the magnitude of 3 by 2 Vm, and this is the a circle, a magnitude of 3 by 2 Vm, 3 by 2. And this is apply as a circle and rotating like that. It is not an ellipse because of the every point the magnitude of a three phase system is constant as a 3.3 by 2 Vm only. The magnitude if you take as B R by B, it will be a 3 by 2 Vm at any point. That's why this is the circle of 3 by 2 Vm. Origin is the 0. Origin of this one is the 0 0. At same point 0 0. The 0 0. It asking about the question 1. Referring to question 1 and one question the Vm is 10.
The circle with center.
Yes, circle a center of 0
With
0.
center 0, 0 and radius 15.
Yeah, the Vm is 10 in question number first. 10 sin omega t something. The Vm is
Okay.
10, then it will be a 3 by 2 Vm. The radius of this one 3 by 2 Vm, it will be a 15.
Okay.
In a single phase transformer, turn ratio of 1 and to 1, primary of the transformer is sorted and inductance measured from the secondary side is observed as 1 millihenry. LS1 is the primary leakage inductance, LS2 is the secondary leakage inductance, and LM is the magnetizing inductance of transformer referred to the primary. Then which of the following statement is true? The transformer referring equivalent of inductance is denoted as like that. This is the 1:1 ratio. Then inductance of secondary got if transferred to primary, it will be same because of the turn ratio is same. This is the LS1. This is the LS2. A tends to LS1. A square tends to LS1, LS2. But A square is 1 because of turn ratio is 1. Then this is the same. This will be LM. This is the primary side. This is the secondary side. The question is saying that primary of the transformer is sorted. The primary is sorted like that. Sorted. Okay. Now observe secondary side is the inductance measured from the secondary side. Then what is the L equivalent is also given as 2 millihenry. Sorry, 1 millihenry. Then this is the asking about the what is the statement is true. This one, all of things. Okay. Both are in parallel connection. L equivalent will be LS7 parallel of LM plus LS2. This is SL1 into LM divided by of LS1 plus LM plus of LS2. You can take LM common here. This is LS1 divided by you can take LM also common here. So LS1 divided by F LM plus 1 plus of LS2. LM will be cancel out. The primary inductance is very low as compared to the magnetizing inductance of a transformer. Magnetizing inductance of transformer, if in 100 millihenry, then the inductance of a primary winding leakage inductance. This is not a primary winding inductance. Primary winding inductance to be higher, but this is the leakage inductance only leakage fluxes linkage. What is the leakage fluxes only affected the inductance? Then these inductance is the only for the leakage inductance. The leakage inductance is very low as compared to the magnetizing inductance. Then LM is very larger than the LS1. Then this is the you can take as a neglected item, neglect part. You can neglect this one. Then overall is one LS1 plus LS2 only. This value is very low. Then both are the equal because of the turn ratio is the same. This will be 0.5 millihenry and 0.5 millihenry. This is 0.5 millihenry. But if we talk about the magnetizing inductance, it will be very high, like 100 millihenry, okay, approximately 100 millihenry. That's why it's very large. Okay, then this statement is true. LM is not lower than this one. This is very low value. LS1 and LS2 both are 1 millihenry. No, total inductance is measured from secondary side is 1 millihenry. That is no. This is option is true. C. In a grid connected application, in order to track the angular position of a grid voltage using a PLL, then which of the following is done? Q axis component of grid current reference IQ is said to be 0. Projection of grid voltage space vector along Q axis of a stationary reference frame is used. D axis of the synchronous rotating frame is aligned with the grid voltage space vector. Projection of a grid voltage space vector along axis of the stationary reference frame is used. In a grid voltage, to controlling of a grid voltage or tracking of the grid voltage, the VD, VQ are used because of the VD and VQ is a constant value only. And you can compare from output voltage to the reference voltage. Then you can use a simple controller, PI controller, to track the voltages. But in grid character system, it also done by one reference point is going to the 0. If one axis is 0, then all of voltage appears on the one axis only. Suppose like a VQ, this is the alpha and beta axis. D and Q axis. A magnitude of voltages, some voltages is used like VG, VG, uh, VA, VB, VC at any point. It will be some voltages like a 3.2 Vm like that. Some voltage it will be, you can use the VG is here. This is the VG. VG can be divided in two portion VD and VQ. We will take this is angle, some angle theta. Then there is some VGDQ axis, VGD, and here is the also VGQ. This is the D axis. This is the Q axis. To track in a grid system, to track the voltages, the VQ voltage do the VG voltage as a 0 by using a controller. If this is the 0, then whole VG is the same as the VD. If VQ is a 0, then VG is the same as the VD axis. Then you can use only one axis or VD axis. If you take VD is same as the VG, then if you control the VD, then all of voltage magnitude will go, you can control. That's why in the three phase grid system, the one advantage is also here. If suppose some current is also here, IG. IG has also some component of D axis and Q axis, IGD, and IGQ. There are some angle difference, VG and IG. There is a phi, is a power factor angle difference between VG and IG, voltage and current of a grid system. To controlling them, if you suppose if you VD, if Q axis of the VG is 0, you can do this will 0. If you 0 then 0 do the 0, then if current also if you do the 0 at a Q axis, then all of the current magnitude are same as the D axis magnitude, IGD. In this condition, you can look here then both VG and VGD and IGD is just in the same phase. The angle difference between them is 0. It means in that time the reactive power will be 0. Because of the angle difference is 0, reactive power is VI cos sine phi, sine 0 is a reactive power 0, only active power is there. That means this is used for the power factor correction also. That's why the q axis of the magnitude will be 0 are used in a grid system to track the angular position of the grid voltages.
So excuse me, sir. Sir, for unity power factor,
Yeah, yes, yes,
so in order to deliver for the unity power factor in a DQ frame,
yes.
can you tell, sir, how to get unity power factor?
You have a two frame, na? You have a two quantity like V D axis and Q axis.
Yes, sir.
Suppose if you take a VD and VQ, it will
Yes, sir.
compare some VD. This is the reference signal.
Yes, sir.
This is the VQ from the grid system.
Mm.
If you can do this, will be 0.
Mm.
Then output of will be 0. It will be maintained by controller. There is some controller is used. Suppose if you use a PI controller, then the error will be 0. If a PI controller is used, the error will be 0. Then error is 0. It means VQ also 0 of a grid system. Grid
Mm.
system, the component of the quadratic axis will be 0. Same thing you can apply for the current also. ID
Okay, sir.
and IQ. ID reference and ID. You generated two four things: VD, VQ, ID, IQ to control the
Mm.
power.
Mm.
Then this is the same thing you apply a controller, PI controller here. Same PI controller apply here. Error will be 0 for both. If you, this is the set reference set for the grid system. If you take this one is the, as a reference, like if you want to, this is the 400 volt and this is a 0. Then same as this is the VG, the output voltage of the grid of output of the system, inverter system. This is all of thing controlling of the inverter switches. If you decide a current, some current, and the power will be delivered like a 5 ampere or something, then they do the IQ as a give the IQ as a 0 reference.
Mm.
Then IQ of the grid system also 0 because of the controller. You have use of controller, the value of IQ will be 0, VQ will be 0, then VD and ID in a aligned with the same
Same.
position.
Mm.
Then the angle difference will between VG and this is the IG will be 0. And that condition, the reactive power will be 0. You know,
Okay.
if you this type of signal is generated in a generation mode like PV generation mode and wind turbine wind
Mm.
system, use the motor inverter drive from the motor, inverter drive the motor, sorry, motor is generated some voltages. These voltages are converted into DC. Again DC voltage is converted into AC by the inverter in a wind system. Because of the wind system, if the motor is used, the motor will be generated at the AC signal. And the wind AC signal is generated, it will convert it into DC. After DC, it will convert it into AC by
Okay,
the
sir. Okay,
inverter
sir.
after the give to the grid. So to give the grid voltage are controlling like that. In this system, you can say that the overall active power will be delivered only. Reactive power will be taken from the system will be 0. By the system is 0. The whole system is not taken as the reactive power from the grid. It means that. So you deliver at the at a unity power factor. In a grid connected application, if the grid voltage space vector is aligned with the D axis, then the order to inject power to at unity power factor into grid, which of the following is done? Same thing I will already say. D axis will be aligned with D axis, then Q will be 0.
Mm. Q will be 0.
But it's given as the voltage space is the voltage space vector along with the D axis. Then the order to inject power at unity per factor into the grid, which of the following is done? The IQ is 0 is a different thing, but D axis of the synchronously rotating frame is aligned with the grid voltage space vector. It means VD aligned with the VG. Yeah, this is already given in the. This is the if you take a IQ is 0, then VQ will 0 because of this is given the aligned system. Here, grid voltage stress vectors align along with the D axis already given. It means the VQ already 0. Here, all VG is a VT. The question already given. Then current will be 0. If IQ is 0, then whole of the power is delivered by the in a UT power factor. Yes, option A is correct. A DQ transformation is applied to a set of the balanced time varying three-phase voltages at a fundamental frequency. It means the theta will be given as the fundamental frequency omega 1 t in a DQ axis. The voltage has a fifth harmonic component in it. It means supply voltage have a fifth harmonic component also. After transformation out to DQ axis, the DQ axis component will be D axis component. Asking about the D axis component. To find the D axis component, first to find out the alpha beta. The system is given as the fundamental and fifth harmony. It means you can say like V A is equal to Vm sine omega t plus B of sin Vm sine 5 omega t. Vb Vm sine omega t minus of pi 2 pi by 3 plus of Vm sine 5 omega t minus 2 pi by 3. Vc Vm sine or the fundamental Vm sine omega t plus 2 pi by 3. In fifth harmony Vm sine 5 omega t plus of 2 pi by 3. Okay. You know about when if you convert this all of thing into VD, this is same as VC in fundamental, then VD and VQ have a constant DC voltage because of it is rotating at the same fundamental frequency. It means omega t only. Theta also omega t. It means there is the some DC voltage VD and VQ is fixed. Then this is the DC voltage is fixed. Plus, due to the this fifth harmonic component, it have some harmonious component also. Then what is the value of this one? Option is also given as the only DC or some harmonics. Fifth harmonics, fourth harmonics, or sixth harmonics. What this one? Only DC. DC is there. Okay, by this system ABC, DC component will be there. But because of the fifth harmonic component, some harmonic component also there. It only not only DC. This will be the incorrect option. And I will calculate only for this one. For this one, I have some DC component. I left this one and calculate the alpha, beta, and VD, VQ for fifth harmonic component. Then what is the V alpha? V alpha is VA minus 1 by 2 VB minus 1 by 2 VC. VA is Vm sin phi omega t. I take as Vm is common, sin phi omega t minus half VB sin phi omega t minus 2 pi by 3. Omega t you can multiply by pi also. This will be a 10 pi by 3 minus half sin phi omega t plus 10 pi by 3 minus 1 by 2 you can take common, sin a minus p, sin a cos b, cos a sin b. If you take a minus, this will be plus phi omega t into cos 10 pi by 3 minus cos phi omega t into sin 10 pi by 3 plus sin phi omega t into cos 10 pi by 3 plus cos phi omega t. This is sin phi omega t into cos 10 pi by t, 10 pi by 3 plus, then this is the plus cos phi omega t into sin 10 pi by 3. This will be cancelled out. Remaining Vm, this will be sin phi omega t cos 10 pi by 3. It means cos 600 is a minus 0.5. Minus 0.5, it means minus of half into this will be a minus half sin phi omega t. This same thing, this will be 10 pi by 3 minus also sin half sin phi omega t. Half, this will be same as this will be minus sin omega t, minus minus will be plus Vm plus half sin omega t sin phi omega t, 1 plus half is 3 by 2 Vm sin phi omega t. This is the V alpha. V beta, V beta is root 3 by 2 VB 0 plus root 3 by 2 VB minus root 3 by 2 VC. Root 3 by 2 VB also have a VM, then I will take a VM as common. VB is sin 5 omega t minus 2 pi by 3. Sin 5 omega t minus 2, 10 pi by 3 minus, this will be a sin 5 omega t plus of 10 pi by 3. If you solve this, so this one, you get the root 3 only, root 3 5 omega t here. In this, the 5 cos 5 omega t into sin 10 pi by 3 is cancelled out, because of, if you take a, you have taken as the negative common, that this is the positive, sin 5 omega t plus 10 pi by 3 plus is there, but here is the minus, then this portion will be cancelled out in this condition. Then minus cos omega t sin 10 pi by 3, sin 10 pi by 3 is this is negative, this is also negative, negative sin pi by 3 minus 3 by 2 minus root 3 by 2 minus root 3 by 2, then minus 1 minus will be plus root 3 by 2, root 3 plus root 3 by 2 is root 3 sin pi 5 omega t only remaining here. Sorry, this is a cos, the cos is the sin pi by 3 is root 3 already taken, then cos 5 omega t only remaining here. This will be 3 by 2 Vm cos 5 omega t. This is the alpha, this is the V beta. Find any one Vd at Vq, and you can get the Vd. Vd is V alpha cos theta plus V beta sin theta. Theta is a fundamental. Fundamental is omega t only, 1 omega t. Theta is equal to omega t only. The fundamental is given. Vd reference is rotating at a fundamental. Then V alpha is 3 by 2 Vm, 3 by 2 Vm, 3 by 2 Vm in both, then 3 by 2 Vm is common. V alpha is 5 cos omega t, sin 5 omega t into cos theta. Cos theta is cos omega t plus V beta. V beta is cos 5 omega t, cos of 5 omega t into sin theta. Sin theta is sin omega t. This value is 3 by 2 Vm. Sin a cos b, cos a sin b. It means sin a plus b. Sin a plus b, it means sin 5 omega t plus omega t. 3 by 2 Vm sin 6 omega t. From Vd, you can say sixth harmonics are present. Harmonics component are present. Plus DC. DC value of Vd, some DC value plus DC value plus 6 harmonics component. because of this one Vd. The following statement indicate the characteristic of the power semiconductor switches that are used in the inverter circuit. Which of the set of characteristics are necessary and sufficient? First one is the bidirectional current carrying capability. Second one, bidirectional voltage blocking capability. Third one, the unidirectional current carrying capability. Fourth one is unidirectional voltage blocking capability. You know about where the inverter, MOSFET or IGBT are used. IGBT is used with anti-parallel diode, and the MOSFET I have already a body diode. We talk about the MOSFET. It have some this type of configuration. Inverter, in three phase you have a three legs, and one leg switches are like that. This is the voltage, this is the I VI characteristic. All of you know about the characteristic of the MOSFET. If you apply a MOSFET some voltages, then it will be blocked the some voltage till the gate pulse is not given to the MOSFET. It means it have a blocking capability. By suppose that in directional, if positive voltage is given here VDS, this is the drain, this is source, this is the gate. Some voltage is given here, then it will be some voltage blocked, some voltages till the gate pulse is not applied here. If you given the gate voltage, then this will be turned on and it will work like a short circuit. But when gate pulse is not applied, then voltage will be blocked. And this is the voltage blocking capability in one directional. Okay. If a switch is on, then current will be flow. Then this is also current will flow in a positive direction. Current is flow like that. Okay. In two direction is the here voltage applied is positive. Suppose if you apply a negative voltage, then what happen? In MOSFET I have body diode. In IGBT, if you used in the inverter, then it should have some anti-parallel diode also. It must be used in inverter. Then this diode, if you apply the positive of diode is this way, anode and cathode, anode will be positive, cathode will be negative, then diode will be forward bias directly. It will not blocking any voltage in this condition. Because of the diode, it will flow directly, current will flow directly, it will not blocked. Here is blocked only one direction. It one direction is blocking capability switches, MOSFET or IGBT. If a diode are used, then if you apply a negative voltage, then diode directly flow the current. It will not block the any voltage. That's why it have a blocking capability in the one direction and current carrying capability in both directions. Then what is the option is bidirectional current carrying capability. Yes, it will current flow positive to negative, negative to positive through a diode. One is correct. Bidirectional voltage blocking capability. No, only one directional blocking capability. If a diode is not there, then the voltage is blocked by MOSFET also. But a diode is present. Same thing if in IGBT also. If a diode is not there, then it will block the both direction. But anti-parallel diode is used in inverter. That's why the bidirectional is not there. Bidirectional voltage blocking capability is not there. Unidirectional current capability? No. Bidirectional current capability. Unidirectional voltage blocking capability? Yes. 4 and 1. B option. 4 and 1 is correct. Okay, everyone, I want to stop here. Today
Last
class.
question, sir.
Yes, yes,
Sir, now we are using PLL now, sir. So
yes,
in
yes.
order to determine grid voltage phase angle or
Nah,
voltage
this is angle and frequency by PLL.
both.
Yeah.
Yes. Thank you, sir.
I think you have class tomorrow also at the same time. Instead of the 17 October, I will not available at on 17 October. That's why I will take a class on tomorrow. Tomorrow same timing 7 to 9.
Okay, sir.
Yes. Okay then.